Hey students, we are studying lesson 7.6 and we're going to be solving equations with addition and subtraction today. Let's take a look at your bell work first. Okay, so here is your bell work. Let's take a look at number 1. And on this one, it wants us to write an inequality for the number sentence. And so our first one is x is less than or equal to 18. So we're going to go x is less than or equal to 18. And if my handwriting isn't as good today, I'm using my finger because I forgot my stylus at school. So I'm at home doing this, and so my stylus, I forgot it. So the next one, x is greater than negative 91. So we have x, and we know it's greater than negative 91. And our last one, x is greater than or equal to 21. So x is greater than or equal to 21. So there is number 1. Number 2, it wants us to find the volume of first of all, it gives us the volume and it wants us to find the missing dimension. So if you remember, the formula for finding the volume is length times height times width equals volume. And so I'm going to set that up by just plugging these in for what I do have. Do I have the length? I do. So it's 9.3 times, do I have the height? I do. So I can put in 5 and 2/10 times x equals, I need to scoot this over a little bit, 120.9. Okay, so from here, we're just going to multiply what we do have, and so it's going to turn out to be some number x equals 120, and then we can use railroad tracks to figure this out. So we're going to go 9 3/10 times 5 2/10, and that gives me this number, 48 36 x equals, now there's where our railroad tracks come in, 120 9/10. So from here, we're just going to use inverse operations. So again, we're going to, because that's multiply, we're going to divide by 48 36 hundredths. That gets rid of it, leaves us with x, but what we did here, we have to do over here. So we're going to divide by 48 36 hundredths, and that's why we use calculators, because that one's not very friendly. 120 9/10 divided by 48 36 hundredths, and we end up with 2.5, or 2.5, or 2 5/10, depends on how you want to say it. So put a box around it. Now, if we plug that in, let's see what happens. 9.3 times 5.2 times 2.5, and if we hit enter here, it should equal 120.9, and it does, so we know we have the correct answer on that one. All right, let's look at this story problem. Okay, so this one's kind of a blast from the past. We haven't talked about these for quite a while, but let's read it. Sebastian carried 1/2 liter of water on a hike. He drank 2/3 of the water. So can you see how we have of underlined right here? Of. Remember what of means in math? It means multiply. So we want to take 2/3 of a half. So 2/3 of means multiply 1/2. Now, do you remember we can cross simplify? We can just go 2 times 1 is 2, 3 times 2 is 6, and then simplify. Or we can simplify right here. So we can go 2 goes into 2 once, and it goes into that 2 once. So we get 1/3. So he drank 1/3 of a liter. That is the answer to the bell work. All right, let's take a look at our notes. All right, here are the notes for solving inequalities. And you guys, it's just like equations, except with a couple of little tiny changes here and there. But you don't always run into those. So I just want to go over the rule, kind of what our checklist is, if you will. That's kind of what we are looking at here. Number one, we're going to use railroad tracks. We're going to use the inverse operation like we always do. We're going to solve and box the answer. Make sure the variable is on the left. This is huge. If it is not, flip the entire inequality. So I'm going to do one that's like this, that has the inequality or the variable on the left. And then I'm going to do one that has one on the right. And we're going to talk about that and see the differences. And then when we're graphing them, you always need that x, or the variable, on the left-hand side before you try and graph it. And we'll talk about that a little bit in just a minute too. So let's solve this really quick and see if we go through our checklist. So number one, railroad tracks. Now, remember, we're going to use inverse operation. This is subtracting 9, so we're going to add 9. When we do that, that leaves, we're left with n. Bring down our inequality, and we have to add 9 on this side. 2 plus 9 is 11. Now, if I do 11 minus 9, do I get 2? I certainly do. Now, this is our answer right here. N is greater than or equal to 11. Now, if we were to graph that, so I'm going to put a straight line right here. Well, we would go to wherever 11 is, right? So let's say 11 is right here. So we're going to go 11, and then, well, I don't like where I put the 11. I'm going to change where I put that 11. It is not a good place. So we're going to go, and we're going to put the 11 right here. So that, let's say that's 11. And it says it's greater than or equal to 11. It's greater than or equal to. So we're going to fill it in with a whole circle, right? And our arrow goes this way. And that is how you graph it. Okay, now that we've seen one where the variable is on the left-hand side, I'm going to erase this really quick. And let's look at one where the variable is on the right-hand side to see what the differences are. Okay, so here is an inequality that has the variable on the right-hand side. So we're going to solve this just the same way that we always solve equations and other inequalities. So there we go. There's our railroad track. We can see that we have the variable over there. We want to get it by itself. We're going to add 7 to both sides. That gets rid of it. We're left with m. We add 7 here, which is 15. Let's see if we plug in 15 if it works. What is 15 minus 7? 8. So we know that, oh, and you know what I didn't do? I didn't make that an inequality. So that says 15 is less than or equal to m. Now, here's where things are a little bit different with these guys. If your variable is on the right, it makes it really, really difficult to graph from there. So what you have to do is you have to take the inequality and flip the entire thing around. So we're going to just flip this and call it m is greater than or equal to 15. So if you think if 15 is less than or equal to m, then m is greater than or equal to 15. You can say it in two different ways. And I know that that's kind of difficult to kind of wrap your mind around, but if you just can remember, if the variable's on the right-hand side, we take the sign, everything, and we just flip it all the way around. And so we end up with m is greater than or equal to 15. Now, we are going to graph this guy. And here is our little number line. Let's say that 15 is right here. And it is a closed circle because we are dealing with an equal sign with it. So it's a closed circle at 15. And then our arrow is going to go that way. So really, that's what it's talking about here. It says when the x is on the left, graph the direction of the sign. So just do what you normally do. When it's on the right, swap the inequality, including the sign, and then graph the direction of the sign. So if you have the variable over here and you've swapped it around, you graph it just like normal. Easy peasy. All right, guys, let's take a look at your practice. So this practice right here, we're talking about taking and change. This first section is change the variable to the left side and then graph the solution. So let's take a look at number 1 here. And it just wants us to get in the habit of just flipping it all the way around. And the way that I kind of look at this is it's looking, what would it look like if it looked at itself in the mirror? So I like to draw a mirror right here and then just go, well, the n would be, it doesn't change the value, it just stays the same. It just looks, it's like it's looking at itself in the mirror. So now it wants us to graph it. So remember, we don't need this guy anymore because we just came up with our new and improved inequality. So let's just make a place where 10 would be. I like to choose the middle of my graph. So there's 10. And it is less than or equal to. So it definitely is a circle at 10. And then my arrow goes that way. Okay, so let's take a look at number 2 now. Number 2, we're going to flip it around because the variable is on the wrong side. So again, I like to draw my mirror, and then it's looking at itself in the mirror, so it just looks like that. Okay, so there it is. We just took it. It didn't change the value. It's now v is greater than or equal to 14. So we're going to go, okay, you know what? There's 14. It's a full circle because it is an equal sign. And then we are going to graph with the arrow going that way. Looking at number 3, again, practicing this same thing over and over again just so you can get the hang of it. So P is greater than 21. Now here is one that there's no equal sign. So we need to decide where 21 is going to be. We'll say 21's here. And then it is an open circle. And if you would like to use a little that instead, whatever helps you to distinguish that it doesn't include 21. It looks like that. And our arrow is going to go this way. So hopefully you're getting the hang of this. Again, sometimes they want you to list some of the numbers that it includes. Like we would go 10, and it's everything less than 10. So 9, 8, 7, 6. You can do this if you want to. I'm just going back to kind of show you that some of these, so it's everything greater than, so 15, 16, 17, and so on and so forth. And then this one would be 22, 23, and 24, and then you keep going. You could keep going if you wanted to. Now we're looking at this one. Same thing, we're practicing again. Let's draw our mirror, and then we go x is less than 3. So we're going to come down here and decide where 3 is, and it is an open circle. So we're going to make an open circle, and it is less than. So everything less than 3. So 2, 1, 0, -1, everything that's less. And number 5, again, draw our mirror. There's our mirror, there's K, and there you go. K is greater than 20, so we put a 20, a circle, and that way. All right, even with negatives it works. You're going to go, here's my mirror. W is greater than or equal to -2. It's going to be an open circle, or a closed circle, I'm sorry. And we're going to call that -2, and it is everything greater than -2. So there we have -2, -1, 0, 1, 2, 3, and so on and so forth. All right, pretty easy on that part. Now it wants us to solve some of these inequalities and then graph them. So we're going to practice what we did on the notes. You saw that. We actually did this one in the notes, so I'm going to skip this one. That was the first example we did in the notes. And then let's get to this one here. So I am going to, first of all, draw my railroad tracks. And then I'm going to subtract 10. Remember, inverse operation. It leaves us with V. Bring down my inequality. And we're going to minus 10 from here. And we get 4. So is 4 plus 10 14? It certainly is. So we go like that. And then we come down here and decide where 4 would be. I like to kind of choose the middle. And it's a closed circle because it equals it. And the arrow goes this way. It's V is less than or equal to. So 3, 2, 1, 0. All of those would be solutions for that. Number 9. Let's have you try number 9 on your own. When you're done, unpause and see if you get the answer correct. All right, did you get P is less than 44 as your answer? If you did, and your graph has an open circle and an arrow moving to the left, you got it correct. All right, let's take a look at another one, number 10, and let's see if you can do number 10 on your own. So give that one a try. When you're done, unpause. Okay, if you got x is greater than 12 and you have an open circle on your graph and the arrow moving to the right, you have that one correct. Let's see if you can do number 11 now. Try that one on your own. Actually, I lied. I want to go over this one because the variable is on the right-hand side. So again, variable is on the right-hand side. We don't treat it any differently. We just want to subtract 15. It's the inverse operation. We're going to subtract 15 from here. It gives us 5. Bring down our variable. Bring down our k. Now, here is where you have to remember the mirror, right? So here's our mirror. We have k is greater than 5. Now we're going to graph it. So let's put 5 there. It's an open circle. And my arrow is moving to the right. So 5, 6, 7, 8, and so on and so forth. All right. Let's take a look at number 12 now. Again, I want to see if you can do this one. So when you're done with it, unpause it and see if you get it correct. All right. If you got m is greater than 15 or greater than or equal to 15, you got it correct. Remember, variables on the right-hand side, you have to flip it around. And so 15, 16, 17, and 18, and so on and so forth would be the correct answers or solutions for that. And did you recognize that that was the example I used on the notes? Good job if you did. All right, let's see if there's any other questions on here to do. No, we got that done. So let's look at the assignment for today. All right, guys, I'm looking at your assignment here. 1 through 12 looks pretty self-explanatory, stuff that we've been doing in the notes. Now, word problems, turning those tricky words that and again, I'm going to tell you this. You have a cheat sheet that's on your Go Formative. You have a cheat sheet in your journal. You can use that to help you out here if you need to. And I'm going to underline the words that are kind of what we're looking for here. At least. That's the word you want to look there. Let's see here. Can store up to. Okay, that one might throw you a little bit, but think about it. Logically, a memory card on a cell phone can store up to 50 phone numbers. And there's 20 phone numbers stored on the cell phone. I think you can do that one if you try it. At most. That's one of those words that we've been talking about the last few days. And then this one, at most again. So take a look at that. Try your hardest on those story problems. If you can get those story problems correct, man, you are doing awesome. And you are doing math at a high level. So if you could, really, I hope that you try and endure through some of this. Math is one of those things, the more that you have to think and try it over again and try things, the more you learn. So I would really hope that you as students will take the challenge to try some of these. Again, if you get it wrong, it's not the end of the world. You can try it over again and try and get the right answer. So I really hope that you try your hardest on these. And again, if you get something wrong, try it over again. All right, guys, until next time, we'll talk to you later. Good luck.